Okay, for this part of the leveling up exercise, we're going to use the Adventure Juice example. So as it says here in the text, we're checking the manufacturing process. We have 8 days of data for 8 days of manufacturing, 100 records each. And the first thing we want to do is see whether or not we're actually hitting our target of being under 64.05 ounces. So I'm going to go over to Jump now. So here I have Jump open, and I've given you applejuice2.jump. So if you don't have that yet, pause and download that to a place where you can access it, and then you can click right on it, and it should open up, and you'll see that the data is organized in what we call a thin format. That means we have one variable for each of the days, and then one for all of the measurements. So we actually have 800 measurements right here. This is conducive to calculating the average for all of the days all at once. We could also make the data fat by rotating it so that we had one column for each day, and then that would make it easy to compare day by day. But we won't do that for this particular exercise. So as we always get started, I'm going to go ahead with Analyze, and I'm going to say Distribution, and I'm going to put Measurement in to the Y columns. And then I'm going to click OK. And I'm also going to change this around to be stacked so that I can see it sideways like this. And I'll just expand this out so that everything is visible. So first of all, we'll note that many of the readings are around the 64.05 range, but we do have some readings that are much lower, and so that's going to be a concern. So think about whether or not we should delete these measurements and call them an outlier. Okay, let's start by testing whether or not the mean is equal to 64.05, which is what they said they wanted the bottles to be filled to, maybe a little bit under that. I'm doing this to illustrate what a two-tailed test would look like, and let's see the actual statement of the two-tailed test. So we would say that the null hypothesis is that the mean is in fact equal to 64.05. And the thing that we're interested in finding out is the alternative hypothesis, and that's whether or not the mean is not equal to 64.05. So to carry this out, I'm going to go to the red triangle here, click on it, and I'm going to say Test Mean. Now we don't know what the true standard deviation is, so we're not going to do a z-test here. Most cases in the real world, we do not know the true standard deviation because that requires having all of the population data. So we'll specify a population mean here of 64.05, and then we'll click on OK. And now we have to interpret the results that we've gotten here. Here are the test statistics that we got. And so it's always a little bit confusing to interpret what Jump is doing here, because it has its own particular ideal of how it wants to present the information to you. So the key thing here is to see this where it says probability greater than t, and it's talking about how it's interpreting whatever test it shows you up here. This is the t-test, and this is the test statistic, which you may have seen in your stats class. So with the two bars here, we mean probability greater than the absolute value of t, and that means that we're doing a two-tailed test. So 2 bars equal two-tailed. That's how you can remember that. And now we see what the p-value is, and we can see that it's less than 0.05, so we can conclude that we can reject the null hypothesis. So in rejecting the null hypothesis, we are concluding that the alternative hypothesis is sufficiently true, that is to say, it would be sufficiently unlikely that we would conclude this and we would still have the null hypothesis be true, that we can say that the mean is not equal to 64.05. The question is whether or not this is actually a useful result for us, because remember in the problem it said that we wanted to have a test of whether or not the mean was less than 64.05. So that means we need to do a one-tailed test. So let's look at what the expression would be for that hypothesis. So here we're saying that the null hypothesis is that the mean is greater than or equal to 64.05, and the alternative is that it's less than 64.05. So remember, the alternative hypothesis is always the thing that we're interested in finding out, whereas the null hypothesis is always the thing that we think is the uninteresting result, or the one that we don't want. So how do we find out what the result is for this one-tailed test? Well, the key here is this less than sign. And up here in JMP, you'll see that one of the things that it reports is probability less than t, and then it says, again, a p-value of 0.0001, which is significant. It's less than 0.05. And so we can, again, reject the null hypothesis, and we can conclude that the mean is, in fact, less than 64.05. Now, it's not unusual that we would conclude that, because the actual estimate of our mean is 63.4, and that is a value that's less than our hypothesized value. And JMP is even showing us this by putting this little bar down here so that we can see how it is relative to the mean that we have actually hypothesized here. You may recall from reading the problem that, in fact, they wanted to fill the bottles a little bit under the 64.05. In fact, they'd really like to hit the mark of 64. And so we can infer that their comfortable zone would be 63.95 to 64.05, that would be something that would be sufficient for them to carry out. And so what we can do is we can use what's called a test of equivalence to see whether or not we have hit both of these hypotheses. And that is to say, the second hypothesis is going to be whether or not the mean is less than or equal to 63.95 or greater than 63.95. So where did I get 63.95? Because I subtracted 0.05 from 64. Here in this one I added 0.05 to 64. So I'm taking the range of 63.95 to 64.05. So first of all, let's do this one-tailed test and see what result we get. So up here I'm going to take away this test mean, remove that test, and I'm going to go back and I'm going to say to my measurement here, and I'm going to say test mean, and this time I'm going to put in 63.95, and I'm going to click on OK. And so now my alternative hypothesis is that it is greater than 63.95, so I need to look at the test statistic with the greater than, and I can see that, in fact, I am not able to reject the null hypothesis in this case. So I cannot say with any assurance that the mean is greater than 63.95. And again, we see that the value that's being reported is lower than that, so this is not a result that we would be surprised at. JMP provides a means of actually carrying out this test directly. If I click on the red triangle and I say test equivalence, this is a TOST equivalence test for the sample mean and a target. And so don't forget that in the JMP Start Statistics book there is a little section on the TOST, and I think it is probably the most convenient way when appropriate to use these one sample tests. So I'm going to click on that, and my hypothesized mean is now 64, and then my difference is 0.05, and that's going to check the range above, or within this range of 63.95 to 64.05. I'm going to click on OK, and now I get some new output here. Let's expand this out. And you'll see that here is the range that I've hypothesized between 64.05 to 63.95. This is the actual confidence interval that it has found of the data that we have. And in order to say that we are within the range that we actually want, this red portion here would actually need to be all the way over here. This portion here would need to go over into within that section over there. And so we can immediately see that we are not filling the bottles with an ideal amount at this point in time. Okay, I'm going to click out of this analysis here, so I'm back to my main data table here. Let's move that down. And now I'm wondering, is there an actual difference between each of the days? Because I do have 8 separate days of measurements here. So remember our mantra of visualize before you analyze. So I'm going to go ahead and use the graph platform. And I'm going to say graph builder. And now I'm going to move day down onto the x-axis. I'm going to move my measurement into the middle here. And I'm going to ask for the box plot. And lo and behold, it looks like we have about 1, 2, 3, 4, 5, 6 days here that are, in fact, doing pretty well. And then a couple of days down here where it looks like things have fallen off. Notice that when I made that box there, I have probably, if I go back to my main data table here, I've accidentally selected a row. So remember our technique, I can click on that in order to unselect it. I go back to my graph here, and now all the points are not selected, so everything looks fine the way it's supposed to be. So this gives me reason to investigate whether or not these 5 days are within our range of 64 plus or minus 0.05, and whether these days are actually out of that range. And we're probably going to conclude that given what we're seeing here, but nevertheless we need to perform the statistical test in order to be sure. So I'm going to click off the graph builder here. And I'm going to go back to my main data table here. And now I'm going to use my handy local data filter. So I'm going to say analyze, distribution. I'm going to put measurement in column here. And I'm then also going to say, oh, I need to go on OK. So I've started my analysis here. Then I'm going to say distribution, local data filter, and I'm going to filter on day. And by the way, something I didn't show you before, on this little red triangle, I can say display options and I can say checkbox. I think that's a nice little way to look at this. Okay, let's expand this out. Let's change this to stacked so that we can see it sideways. Let's actually collapse these things so they're not in the way. And then let's just take day 1. Okay, so there's the distribution for day 1. I'm going to go ahead and I'm going to click here and I'm going to say test equivalence, put in 64, put in 0.05, and click on OK. And so now let's interpret what we see here. We can see that the entire range from 63.95 to 64.05 is highlighted here. And our confidence interval for that day's production sample is actually quite small. It fits well within that range. Notice that both p-values for each of the hypotheses that we're testing are good. They're less than 0.05. So we can say that the mean is equivalent to 64, which is what we are hypothesizing with the toast, because we're doing it both directions for the one-tailed test each in both directions. And we can end up saying that this is, in fact, what we want from our production process. Note here that this is showing us the null hypothesis. If you go back in the video a little while, you'll see that those are exactly the null hypotheses that I showed you. And here the p-value is showing us that we can reject what the null hypothesis is. So it's not showing you what the alternative hypotheses are. To make the spacing fit a little bit better here, what I'm going to do is I'm going to actually, first of all, collapse these again as I open them up. And I'm going to try to open this up a little bit more. I'm going to go to my red triangle with measurement, and I'm going to say display options, and I'm just going to get rid of that quantiles in general. And then I'm going to go back here to my summary statistics display options, summary statistics, and I'm going to get rid of that one. And so now this fits on the screen, so I can see everything. I have day 1 right now. What happens if I change my local data filter to day 2? I'm going to go click, and notice that it's now performed exactly the same test on day 2 and so I can figure out whether or not day 2 is the problem, or if there is a problem with day 2. You should now be in a position to try out some of the other days, and be sure that you have this information available when you are taking the LUG quiz, which is just coming up soon.